Okay, guys, so today we're going to take a look at the Unit 6 quiz review. Okay, so let's start off with number 2. Now, on all these problems, the directions are the same. We are just going to be simplifying. Okay, so we want to get all of these problems down to as few terms as possible. Okay, now, number 2 specifically starts us off with some terms that have some negative exponents, which are a big no-no. Okay, now, first thing I should do, negative exponents, is let's get rid of them. Okay, how do we do that? Well, any term with a negative exponent needs to move to the opposite side. If it's in the numerator, it goes down to the denominator, becomes a positive exponent. If it's in the denominator, it moves up to the numerator, becomes a positive exponent. Okay, so how would we do that? Well, let's take our three terms that are not that do not have negative exponents, and let's rewrite those exactly where they are. X squared over y squared, and then there's also a z in the denominator. Now, three terms with negative exponents, let's move them around. X to the 6th is going to go ahead and come up. Y to the 7th is going to come down. Z to the negative 1st is going to come down, give us positive z to the 1st. And now we are good to go ahead and simplify and combine, right? So let's now start with our x's. I have two x's in the numerator here, x squared times x to the 6th. When we multiply, we add the exponents. 2 plus 6 gives us x to the 8th. That's nice. Moving right along, we have y squared and y to the 7th. Both of them are in the denominator, so we would be multiplying those. So again, we add the exponents. We get y to the 9th. Very nice. Okay, and then the last two terms I don't have circled there are my z's, right? My blue z doesn't have an exponent there, and so I can go ahead and write in a 1. So I have 2z to the 1st, which I go ahead and combine to get z to the 2nd. And now my final answer should have one x term, one y term, one z term, no negative exponents whatsoever. Everything is reduced, and that is our respuesta. Próximo, number 5, or numero cinco for our Spanish-speaking friends, of course. We have a problem here that has an exponent around the entire problem, that 3, okay? So there's a few ways we can deal with that. Now, my preferred method is to keep our order of operations in mind. Good old PEMDAS. Okay, now the 3 here is an exponent, right? Which actually comes second in order of operations. So what I'd rather do is I'd rather go ahead and focus on the parentheses in the time being. Let's look inside of the problem here, see if we can simplify, and then go ahead and apply the exponent at the very end. So inside the parentheses here, very similar to the last problem, right? I have a to the negative 2nd in the parentheses. That's a negative exponent. Let me go ahead and move that first, and then I can keep on simplifying inside the parentheses. So negative exponent, just like on number 2, means I'm going to have to go ahead and move it up to the numerator, and so this is going to become 3a cubed a squared b all over b squared, and now this whole thing is still to the 3rd power. And I don't like that 3, so I'm going to rewrite it. Oh, there we go. Okay. So we're still sticking inside the parentheses for now. Okay. So let's see what we can do. I have a cubed and a squared. Multiplied in the numerator means I'm going to add the exponents. So that's going to give me a to the 5th. 3 out in front here. I can't really do anything with that 3. That's just going to go ahead and stay. And now the piece de resistance, I have b to the 1st power divided by b squared. And so we did not have a dividing example in the previous part, right? When we divide, we have to go ahead and subtract the exponents, right? And so 2 minus 1 gives us 1, which means I have b to the first, and I'm going to put that b to the first where there were more b's, which would be in the denominator. So now I have 3a to the fifth all over b to the first, and now this whole thing is still to the third power. So, order of operations wise, right, I've gone ahead and taken care of the parentheses. I've done everything I could inside that parentheses. Now, let me go ahead and apply the exponent, okay? And so, when I apply the exponent, you can kind of think of this as distributing, right? Every single term inside of the parentheses is going to get that exponent. So, I'm going to get 3 raised to the third power, right? 3 to the third power, 3 times 3 is 9, times 3 again gives me 27. A to the fifth raised to the third power, exponent raised to an exponent, so I have a to the fifth times a to the fifth times a to the fifth, and if I added those together, I would get a to the 15th, right? Which is the same thing as multiplying the exponents, right? 5 times 3, a to the 15th. And then, last but not least, b to the first in my denominator, raised to the third power, means I have b to the first, b to the first, b to the first. 1 times 3, exponent raised to an exponent, I multiply, gets me b cubed, and that looks like a good final respuesta. Okay, let's move on. Okay, now we get to the fun stuff, okay? Let's take a look at number 10. Now, we're simplifying here again, right? Directions have not changed, okay? But the problems get slightly trickier, okay? 4x plus 28 over 4x minus 28. Oh, that's easy. I know how to do this, right? Let's see. 4x's cancel, and then 28 over negative 28 gives me negative 1, right? Nice. Wrong, 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 okay? Hopefully, you're all sitting there saying, Mantra, you so crazy. Although I don't think any of you have actually ever said that before, because, you know, that phrase is from 1993, you know, my era. Actually, that's before my era. I'm not that old. Anyways, where was I? So, remember, 4x plus 28 and 4x minus 28 are expressions. Expressions can only cancel out with the exact same expression, right? So, what we have to do is we have to go ahead and factor numerator and denominator, everything we have there, and see if we can get some common things to cancel out. So let's start with the numerator. 4x plus 28. Hopefully this is an easy factor for us, right? Be careful, there's no diamonds necessary, right? This is just a GCF factoring. So GCF here is 4. I take that out, I get x plus 7. And I believe that's it. Can't do anything else with that. Let's take a look at the denominator. 4x minus 28, same thing, right? Take out a 4 for my GCF, and I get x minus 7. Okay, and now let's see what I can cancel. X plus 7, x minus 7, are those going to cancel? You better be saying no right now. Okay, those are not the same expression, so they will not cancel. However, these 4's out front absolutely will cancel, and so that's going to give me x plus 7 over x minus 7. And so now some of you might be thinking, oh cool, I can cancel out the x's, I can cancel out the 7's, but be careful, right? Expressions only cancel out with the exact same expression. This is why I left the parentheses around the x plus 7 and x minus 7. Okay? So I won't be making that mistake. Alright? And this is another final respuesta. Is that getting old yet? Don't actually tell me the answer to that. Moving right along then, okay? Let's take a look at number 13. Okay? Now, directions here, still the same, simplify, okay? However, we have one thing that's slightly different. We have to multiply, right? I have two fractions here, okay? I have to multiply these. And so, we talked about multiplying fractions the other day, okay? The key thing here is we just have to go ahead and cancel out and simplify before we can go ahead and multiply. That's going to make our work a whole lot easier, right? So, we know how to cancel things out, okay? Let's look for things that are both divisible by the same number, starting with 7 and 35, right? Both of those numbers are divisible by 7. 7 divided by 7 is 1. 35 divided by 7 is 5. How about 18 over 6? 18 and 6 are both divisible by 6, right? 18 divided by 6 is 3, and 6 divided by 6 is 1. And so that takes care of all of my coefficients, okay? Now, the tricky part on this problem is dealing with the x's, okay? I have 4 different x terms here. I have x to the 5th in the top left numerator, x cubed bottom left denominator, x top right numerator. Actually, while I'm at it, that x has an exponent of 1, so I should probably go ahead and just write that in. I'm going to be using it. And bottom right denominator, x to the 7th, okay? So there's a few ways you can do this, okay? I'm going to recommend something that I think is going to be the easiest thing here, all right? I'm actually going to start doing a little bit of multiplying, okay? So multiplying fractions, right? We talked about this. We multiply across, not cross multiply, but multiplying across, right? And so I have 1 times 3, which is 3. And I have x to the 5th times x to the 1st. So I add those exponents, I get x to the 6th. All over my denominators, which again I multiply across. 1 times 5 gives me 5. X cubed over x cubed times x to the 7th, right? I go ahead and add those exponents, I get x to the 10th. And now, right, it's pretty plain, I think, for us to see x to the 6th over x to the 10th. We talked about this earlier, right? Let's go ahead and subtract those exponents. So I'll still have 3/5, right? 10 minus 6 gives me x to the 4th, and since I had more x's in the denominator, I keep my x's in the denominator. So some might say that our final respuesta, although only an idiot would say that, is 3 over 5 x to the 4th power. Okay, this one's a little bit tricky. Okay, there's a few ways you can go about this. I think simplifying your coefficients and then multiplying across, right? And then, where are we here, right? Dealing with these x's by subtracting is the best way to do it, right? You could have gone ahead and subtracted the exponents here, then subtracted the exponents here, and then combined them again, right? But I think that's a lot more work. Okay, so get rid of these coefficients that you can go ahead and cancel. All right, multiply across, add the exponents, right? X cubed x to the 7th gives me x to the 10th, and then we know how to deal with variables that are being divided. We subtract the exponents, ultimate respuesta in the bag. Okay, so one more multiplying example. Okay, this one's got a little bit more meat on its bones. Okay, we have quite a bit going on here, right? The previous multiplying example, we didn't have to do any factoring. Okay, and so, you're going to have a good amount of factoring, so I think we need to review a little bit. All right, so same basic concept as the previous one, right? We want to go ahead and cancel out common things, okay, common expressions like in 2 examples ago. All right, so before we do that, we got to go ahead and factor. So I'm going to take a look at every numerator and denominator here and see how I can factor it, starting with 3x plus 9. This should be a relatively easy factor, right? Just go ahead and take out a GCF of 3, and then divide the two terms by 3, leaves us with 3 parentheses x plus 3. That one's not too bad. Okay. Moving right along, 9x squared is just one term by itself. No friends. Ooh, that's kind of sad. Okay. Can't factor anything. One term, right? Nothing to divide by. And so that's just 9x squared. Okay. We're still multiplying. That's good. Okay. And moving right along, top right, now this is probably the trickiest part of this problem. X cubed minus 5x squared minus 6x. Okay. What's the first thing we always look for when factoring? Hopefully you said GCF. Okay. And so GCF for all three of these terms would be an x. So I can take an x out of all three of those terms. So I divide all three terms by x, and I'm left with x squared minus 5x minus 6. And now hopefully you remember that, hey, x squared minus 5x minus 6, that should just be a pretty simple diamond problem, right? Let's put a negative 6 on top, negative 5 on bottom. So this is going to be negative 6 and positive 1, right? And so my final fully factored answer here for the top right numerator is I had my GCF, I took out an x, and then I was able to factor x squared minus 5x minus 6 into x minus 6 times x plus 1, and I made a t instead of a plus, which is stupid. So that gives me x plus 1. Okay, now last piece of the puzzle here, okay, is the bottom right, x squared minus 36. Okay, hopefully that one's pretty easy to recognize by now, right? Two perfect squares, x squared and 36, right? That is a difference of two squares. If that was x squared plus 36, I couldn't factor that, right? Can't factor a sum of two squares, but a difference factors very nicely into x minus 6 times x plus 6. And now we are ready to cancel out some very nice things here. Starting with, I think the most obvious one is the x minus 6 in the numerator and denominator. Okay, we can get rid of those, all right, and all is good. Let's keep going, okay? Also, right out in front, I have a 3 over a 9, right? Both of those are divisible by 3, and that should give me 1/3. I have x over x squared, right? I have the x that's blue, I have the x squared that's black, right? Remember that x has an exponent of 1, right? So if I'm dividing, I subtract the exponents, right? And so that would give me an x in the denominator, right? 2 minus 1. Okay? And so in the numerator, I'm still left with x plus 3, x plus 1, if I can fit it. Kind of. And in the denominator, I still have an x plus 6. And that, while very poor handwriting, still makes for a very nice ultimate respuesta. Now, if you want an even more ultimate respuesta, right, feel free to go ahead and FOIL out the numerator if you want. And in the denominator, you could go ahead and distribute the 3x. None of those things are mandatory. Okay, totally up to you. Also optional, the 1 in front of the x plus 3 in the numerator, right? This does not have to be here. Okay, I don't have to have that 1 there, right? But you can leave it, doesn't matter. Okay, very nice. Let's look at one more. Alright guys, let's take a look at uno mas. Number 20 is a division problem. Wait a minute, what? Ah! Ah! Division? What do I do? Just breathe. Okay, calm down guys, we're gonna get through this. Whew! Okay. Alright, now, division, whew, okay, I'm ready to go. Dividing two fractions is the same thing as what? Oh, that's right. Multiplying by the reciprocal of the second fraction. So, the very first thing I'm going to do before any type of canceling, any type of factoring, any type of moving negative exponents, any of that is I should go ahead and take the reciprocal of the second fraction. So, 6x to the fourth over x minus 7. I'm going to leave it exactly how it is. Second fraction, I go ahead and take the reciprocal, 7 minus x over 12x. And now my division problem becomes a multiplication problem. Silly mantra, you were worried for no reason. And so now we are ready to go ahead and start simplifying. And so let's do what we do best. Starting with, I have 6 over 12. Both of those are divisible by 6. So 6 divided by 6 is 1. 12 divided by 6 is 2. Okay. Now, the next thing here, right? X to the fourth over x, right? 4 minus my exponent of 1, which would be completely gone, leaves me with 3 x's in the numerator. So I have 1x to the third power there. Okay. And now the last thing here, and this is the thing I think could give some of us trouble, is the 7 minus x over the x minus 7. So I kind of want to do this part separately here. So this is not my final answer. I'm just going to do some scratch work here. And just to remind us of what this is going to equal. So first things first, 7 minus x, that's stupid. The x should come first. Negative x plus 7 over x minus 7. Okay. Also stupid, why does the x have a negative exponent? Or a negative coefficient, excuse me. That seems pretty dumb, right? And so, to make up for that, I'm going to go ahead and factor out a negative 1. And so if I divide both of those terms by negative 1, well, negative x divided by negative 1 is positive x. 7 divided by negative 1 is negative 7. And so I get negative 1 times x minus 7 over x minus 7. And what do you know? X minus 7 cancels out with x minus 7. And this whole thing just equals negative 1. So, long story short, right, if I cancel out my 7 minus x with my x minus 7, I am going to get negative 1, right? That's exactly what we just showed here. 7 minus x over x minus 7 is going to equal negative 1, right? And we talked about this earlier. Opposite expressions give us a quotient, right? We're dividing of negative 1. So let me go ahead and just put a negative 1 up here, right? And now let me go ahead and multiply, right? So what do I have in my numerator? I have 1x to the third times negative 1 gives me negative x to the third power over my denominator. Is there anything in my denominator? Yeah, don't forget about this 2, right? Which we got when we canceled 6 and 12. So in my denominator, I just go ahead and get a 2. And, believe it or not, our ultimate respuesta is negative x cubed over 2. Okay? So don't worry about division problems, right? All you have to do is take that initial first step of turning a division problem into a multiplication problem by flipping the second fraction, right? We take the reciprocal, we flip numerator and denominator, okay? And now we get something very nice here, right? Because we have done a few examples of these and we know how to do those, okay? Last tricky thing here, 7 minus x over x minus 7. Anytime you're dividing opposites, right, you go ahead and get -1. And so we went ahead and put that up right there. And I think that should about do it, okay, for this quiz review. All right, I think we should be in pretty good shape. Okay, the rest of the worksheet is homework. All right, so finish that up. Okay, you have quiz the next school day. All right, and just FYI, respuesta means answer in Spanish. So sorry for confusing you the entire video, if that confused you, which it probably did, unless you know Spanish. Sorry. Bye.